Assalamualaikum and salam sejahtera. My name is Siti Aisha Zulaika binti Ismail, leader of Group 12 of the Solid Programming Cornerstone project. So today, me and my teammates are going to explain on how we do our manual calculation and coding for each of our problems.
So hi, I'll be explaining question one. So based on the question one, I'm supposed to write a computer program for the given shear stress, shear for in x, y direction and tau xy. So for figure 1c, I got this is my sigma x, sigma y, tau xy, and I use general equation to find sigma x prime, y prime, and tau xy prime. This would be my answer for 25 degrees counterclockwise, and this is my answer for 10 degrees counterclockwise. So my orientation would be this one, the one I've underlined, and then for figure 1d, sigma x0, sigma y negative 18, and tau xy is negative 50 megapascal. 25 degrees clockwise, this would be my answer, the one I highlighted, sigma x prime, sigma y prime, and tau xy prime, and this is my orientation. And finally, for 10 degrees counterclockwise, figure 1d, so sigma x prime got negative 90.5 megapascal, sigma y prime, tau xy prime, and that would be my orientation. Moving on to coding. So first, I prompt the user to enter the values of x, y, and shear stress, and then I converted the angle to radian. I use general equation here again to calculate x, y, and tau prime, and print the values. So let me run the program. Figure 1c, it's negative 60, 90, 30, and negative 25. That is my sigma xy and shear stress prime. Again, for now it's for 10 degrees counterclockwise, negative 60, 90, 30, and 10. For figure 1d, be 0, negative 80, negative 50, negative 25. And then finally, for counterclockwise, 10 degrees counterclockwise, 0, negative 80, negative 50, and 10. So this would be my answer. Thank you, doctor.
Hi doctor, so I'm doing question 2. So for problem 2, it requires us to find for the orientation and magnitude of the principal strain, B maximum influence strain, and C maximum shearing strain. And it also asks us to write a computer programming for different values to get the answer that we want. Okay, so now we look into a calculation. So A, this is what I did for A, and my final answer for strain A is 512.5, for strain B is 87.5. And for question B, which we need to find for our maximum influence strain, so what I got is 425. And for C, it requires us to find for the shearing strain, and after I use the formula, I got 513. Okay, and lastly, for the computer programming, I was using MATLAB, as it requires us to put in different value to try to get the answer that we want. So here is it, I put in the formula. Okay, I put in the formula, and for us to put in different value, we can put it here. I already run the program and make sure it works. So that's all from me. Thank you.
Okay, so basically I'll be explaining on question 3 for the problem 3. So problem 3 is asking me to find the bending moment based on the input of the y values from 40 to 0 using 5mm increments. So how did I do that? I'll show you my manual calculation. Firstly, I want to find the calculation of area. So how to find the calculation of area? I use the trigonometric functions, which is using the right angle triangle. As you can see here, I use the right angle triangle to find the values. So I can substitute it in the formula that I created to find my area. Okay, so after finding my area, I calculate my distance, which is the distance from the neutral axis to the center of the yielded area in the stress distribution diagram, and also the triangle over here, D1 and D2. After finding my distance and area, that's how I'll be able to calculate my bending moment. My bending moment is really simple. After getting all the values that I want, I just have to key in into the formula over here, and I'll get my final answer, which is the bending moment. So I'll show you my programming coding. I use Octave to program. I'll just show you. This is the codes. So let me clear this section so I can just show you how it runs. So basically, when we run this thing, I'll have to input the y distance. Please enter y distance. So basically I have like 9 values because like I have to 0.04. This is how I have to enter the y values. 0.04 increment of 5mm, which is increment of negative 0.005, and until 0, right? So we press enter, and that's how I will get my bending moment for each of the y values given. I'll get the bending moment. So this list here shows that from 40mm decreasing to 35, decrease to 30, and so on. So for 40mm, my bending moment will be 837,758 Newton meter, and when it decreases to 35mm, decrement of 5mm, right? So I'll get my bending moment 1.24649 times 10 to the power of 6 Newton meter, and so on and so on. The list continues until the y equals to 0, and bending moment is this one. So it's very easy. That's how I find my bending moment, by inserting the y distance in the coding in the command window. Okay, so that's how I settled my question 3, and that's all for the explanation from my group on our questions. Thank you very much for watching.